So ratio and rates come in the year 7 curriculum, ratios in the year 7 and then ratios and rates in the year 8 curriculum. So ratios are just used to compare quantities, and I've just done a really simple example here. We've got red dots and green dots, and you might be asked a question to write the ratio of red dots to green dots. So if it's supposed to be red to green, now we write ratios, instead of writing 2, we say it as 2, but we write down a colon. So we've got 5 red dots to 2 green dots, and we just use a colon to represent that. So just a simple writing ratios, just like the one on the previous page where we had pictures for it. We could have a sentence like this: there's 32 people altogether, 14 of them are girls and 18 are boys. So we've been asked to write the ratio of girls to boys. So we've got 14 girls to 18 boys. Now, these work a little bit like fractions in terms of simplifying. So we've written 14 to 18, however, they have a common factor, and the common factor is 2. So 2 goes into 14 7 times, and then into 18 9 times. So we can simplify the ratio and write 7 to 9, and it means the same as saying 14 to 18. This helps if we have the understanding of equivalent ratios and simplifying ratios. It makes it easier when you're using ratios for cooking or mixing paint or anything in that real life concept. It's best to have an understanding of simplifying and equivalent. Okay, so the second one is boys to the whole group. So boys is 18 to the entire group is 32. Again, we can simplify. 2 goes into both of these, so 2 goes into 18 9 times, and then into 32 16 times, and we can write it as a simplified ratio. So an example of using equivalents in ratios would be, say, for recipes. So the standard pasta recipe, for example, could be 3 eggs to 2 cups of flour. So I've written it there as 3 to 2. How many eggs do I need if I use 6 cups of flour? So the standard ratio is 3 to 2. Now I've made this side 6 because I need 6 cups of flour, not 2. And you have to work out, okay, well, what did I do to this side? I multiplied it by 3. So if I triple the amount of flour that I need, I also have to triple the amount of eggs. So I would need 9 eggs if I'm going to use 6 cups of flour. So the next part of ratios is dividing or sharing into a ratio. And the standard example that I always use with my students is looking at winning money. So I say, I've gone and bought a ticket to win some money in a raffle, and I've put in $5 for the ticket, but one of my students put in $10 for the ticket. If we win, should we get the same amount? And of course, all the kids say, no, we shouldn't, because I didn't put in as much as what said student put in. And that's the way we explain, how I explain ratios to people and how we divide into a ratio. So I will do an example with you now. So the example that I've got here is share $240 into the ratio 3 to 5. So the way I always do it is I draw up a table. Now the table has to have, if it's got 2 ratios, it needs 3 columns because it has the column for each ratio and then totals column. So if it's got 3 ratios, it needs 4 columns. So we draw in the table. I might actually just draw it a little bit bigger. And it needs 2 rows, always needs 2 rows. So what happens is the ratios go across the top. So that's your ratio across the top. So we've got 3 parts, 5 parts, and then a total of 8 parts. And I've just done like a double line down here, a bit thicker, so you can see that that's the totals column. Now, because that's the totals column, we've got a total of $240 to share between these ratios. So we put 240 underneath the totals. And now we can start to use our equivalent fractions and our equivalent ratios again. So we can say, okay, well, what did I do to get from 8 to 240? What did I multiply by? So I multiplied by 30. So if I multiply one side of an equation by 30, I have to do the same to the other two. So I multiply each of those by 30. 3 times 30 is 90, and 5 times 30 is 150. Now, the good thing with this table method is you can check that it makes sense. So if you have a look at the totals column of the amounts at the bottom, the totals row, 90 plus 150 does give you 240. So you could assume that you have got it right, because if we add up this figure with this figure, it should equal the total that you had to share originally. I'll do one more example of a 3-part ratio, dividing into a 3-part ratio, and then I'll move on to rates. Okay, so this next example is tropical juice is made in the ratio of 2 to 1 to 5, which is apple, pineapple, and orange juice accordingly. How many milliliters of each juice do I need to make 2 liters of tropical juice? So I'm just going to underline some important things here. 2 to 1 to 5, and then we've got the order that it is. It says how many milliliters do I need to make 2 liters of tropical juice. So first indication is it's asking you for milliliters in the final answer. So the best thing for you to do is straight away convert 2 liters to 2,000 milliliters. That's the first thing you should do, because that way it's easier to work with all in the same units than have to change them at the end. So we set up our table. And this time we've got 3 things, so we need 4 columns. And we'll have 2, 1, and 5. And then, of course, we've got 8 across the top. And we've got 2,000 milliliters of juice to work with. So again, we work out what did we multiply 8 by to get to 2,000. That's 250. So we multiply everything on this side by 250 as well. So 2 lots 250 is 500. 1 lot of 250 is 250. And then 5 lots of 250 is 1,250. And then we can just check 1,250 plus 250 is 1,500. And then 1,500 plus that 500 gives you 2,000, or 2 litres, which is what we needed. And then because this is a worded problem, you would answer with a worded answer along the lines of you would need 500 milliliters of apple juice, 250 milliliters of pineapple juice, and then 1,250 milliliters of orange juice. And that would be the end of that question. Okay, so rates are a ratio of 2 related quantities, and they're often expressed as 1 per the other. And the per part is represented with a /. So I've written there a few rates, so like dollars per hour for wages, kilometers per hour for speed, and then dollars per meter for if you're buying textiles or fabric, etc. So often when we're completing rates questions, we're often asked, a car is travelling at 60 kilometres an hour. How far can it travel in 4 hours, or something like that? It's important that students know how to use a rates triangle, and that's what I've drawn here. Now, the most common one is speed, distance, and time, and it often comes up not only in maths but in science as well. And if they can remember how to use these triangles, because they work for all of the rates and they actually also work for trigonometry when they get into year 9, it helps them remember whether they've got to multiply or divide if they can remember how to draw this triangle. So the rate always goes in the bottom left of the triangle. So for this one, I've put kilometres per hour because we're looking at speed. And then in the top part is the left-hand part of the rate. So here, the left-hand part is kilometres, so we put kilometres in the top. And then the right-hand part goes in the bottom. And that is shown here from the fact that it's kilometres divided by the hours. So I've drawn a little divide symbol over this side, you can see. So it should be kilometres divided by the hours. So now we'll answer a few questions and we're going to refer back to this triangle so I can show you how to use it, and then it can be applied to any rate question that you get. Okay, so our first question of the 3 is a car is travelling at 90 kilometres an hour. How far can it travel in 3 hours? So we've got the rate here because it's given by kilometres per hour. That indicates that it is the rate. So 90 kilometres per hour, how far can it travel in 3 hours? So here we're given time and speed and we're asked to find the distance. So if we go back to our triangle, we're asked to find the distance, which is this top part here. We'll just put distance, I'll just write that a bit better. Distance, time, and speed. So if we're asked to find the distance, the way we use this triangle is we actually put our hand over the top of the triangle, which is the one that we're trying to find, and then it tells us that we have to do the speed or the rate multiplied by the time. So if we go back to our screen, we have to do the speed, which is our rate, multiplied by the time to give us 270 kilometres. The second question says, a car travelled 500 kilometres, so that's distance, in 5 hours. So that's time. Now we are asked to find out how fast it was travelling. So we're asked to find the rate here. So if we're asked to find the rate, we put our hand over the rate, and then it tells us we do the distance divided by the time. So our working out would be 500 divided by 5 to give us 100 kilometres per hour. And it's important that you get the units correct. So for this one, it was a rate, so we need to make sure we've got kilometres per hour. So something per another quantity, because otherwise it's not a rate. Like in the first problem is just a distance, so we just have a distance measurement after it. The third question says, how long would it take? So how long would it take a car travelling 75 kilometres an hour to travel 187.5 kilometres? So here we've got the speed, which is our rate. We have the distance and we're asked to find the time. So if we go back to our triangle, we cover up the one that we need, which is, so we put our hand over the hours, and then it tells us, we can just put a division sign over this side as well so you can remember. It tells us we have to do the distance divided by the speed. So if we go back to our question, we need to do the distance, which is 187.5, divided by the speed, which is 75, and that should give you 2.5 hours. Okay, you can also write it as 2 hours and 30 minutes. So it would take this particular car 2.5 hours to travel 187.5 kilometres at 75 kilometres an hour. So that's a bit of a recap on rates and ratios. Quite a long video. Hopefully it has helped. And it's for mostly year 7, year 8, but doesn't hurt for year 9s to revise, because they then, if they're planning on doing essentials in year 11 and 12, it comes up again in year 11 and 12.